There is a lot of interest in this subject. During our substantive discussions, we will discuss experimental approaches to the superconductivity. For today's lessons, we will be discussing energy gap explanation. This topic deserves a lot of discussions. In fact, it is interesting topic to discuss. Insulator band gap. Insulator energy gap is entirely different from the energy band gap, energy band gap of superconductors. The energy gap is insulator result from an interesting interaction between the electrons and the lattices called the electron lattice interaction. Interactions like these bind electrons to lattice. So insulator energy gap means electron to lattice interaction. Vice versa, in the superconductor band gap means it's a electron-electron interaction which order the electron k spaces with respect to the Fermi gas of electron. Therefore, the argument of the exponential factor into the electronic heat capacity of a superconductor is found to be minus Eg divided by 2kBt and not minus Eg by 2kBt. The only in the denominator is 2. This has been learned from the comparison with the optical and electron tunneling determinations of energy gap. We can see the following graphs and images related to the electron lattice interaction in this case. Here when carries, for example, as you know in the particular graph, for example, in the particular graph already we discussed in our previous videos, we discussed briefly what does it means when carry electrons. Conduction means electron and valence means a hole, or introduced to a semiconductor by a band to band photoexcitation or injections. The balance of interatomic force means ionic force mediated by the valence electron is distributed to when the atomic configuration is rearranged. That means the induced atomic displacements in the turn affects the electronic states. This is the origin of the electron lattice interactions in the metallic materials. So the following graphs, as we can see the following, for example, in the particular graph, here we can see that the relations between the electronic lattice interactions. So the electronic lattice interactions in order to understand the interatomic force. Interatomic force through ionic mediated valence electrons. Those following graphs also you can see when carry means the conduction band means electron, and the valence band means, as you need, the whole carry the whole. So which means the interactions between the band to band, that is called the photo excitation. So I don't want to go to more deeply, but in addition we look at here. So there is the auto align band. Before to discuss this one is the direct band gap, and here a indirect band gap. So the direct band gap means it's a allowed transition, right? The indirect band gap, that means it's a forbidden band gap. So what we are going to be understand in the electron lattice interaction means the electron lattice interaction means electrons moving through lattice extracts an attractive forces or nearby ions. Already I mentioned nearby ions means it's called the interbalancing of the interatomic forces. So the electron lattice interaction means the interatomic force interaction. I hope you understand. So the simple way how to say means the energy exchange between the electrons and the lattice. In the following section, the discussion will focus on electron-electron interaction in the origin of many interesting phenomena in these materials. So the electron interaction measurement is based on the metals insulator in transitions order to magnetic and superconductivity, that is successful establishment of a new or a efficient tool for treating the interactions leads to a new paradigm of the condensed matter physics. So what you understand now, this electron-electron interaction means it's related to these materials like a metal insulator transitions. and we are going to be deal with study in the new lead terms about the condensed matter physics. Right. So the following graph, the figure 1 in front of which it's relatively the how the interactions will be facing it in the different form. For example, here as we know as a physics students, we as we know very clearly the electric scattering and the inelectric scattering. So the electric scattering as you know is based on the structural analysis and the HR imaging is called the diffraction. So elastic interactions means it's a diffraction, and inelastic scattering means is called the comparisons of the bonding states. Bond states, what does this mean? The bond state is called the ELS as we know. So I don't want to go too deeply yet. Before that, the electrons interactions in order to understand how with the specimen it's obeying. So the electron interactions means in order to what type of it may be the different reactions may occur when a high energy electron beam strikes a particular specimen. For example, I want to be discussed here to draw your attention is based on the four different points. One is a backscatter electron, and second one is about the electron hole. Third one is about the secondary electron. Fourth one is about the awkward electron. So what does this mean? Backscattered electrons is nothing about atoms and returns into the opposite direction by changing in the direction of 180 degrees, which means it's a backscattered electron. It's a returning back, I mean it's a come return to the opposite direction when the temperature under in the directions of the 180 degree. Right. In addition, the electron lasers means what does it mean? Electron lasers means electrons pass close to atom. Electron pass close to atom, that the sum of the energy is transferred to the electron of the atom. So electron come close to atom, during that time the energy is transferred. The energy transferred, thus that incident is called electron losses. Right. What does it mean the secondary? So secondary electron. Secondary electrons is nothing about electrons separated from the atom. So electrons are separated from the atom that leaves the atom with very little energy. Roughly little energy means how to say in order to understand the 5 electron volt is called the secondary electron means electron separation. When the separation from the atom, when separation from the atoms means it leaves some energy. That energy is called the secondary electrons. And finally, what is the awkward electrons? The electrons to the low energy level causes the energy into the atom. So there is, as you know, the different energy levels. That low energy level causes excess energy into the atom, low energy category. Mm. So this excess energy is compensated by the separation of electron from the outer layer of the atom and the emission of X-ray from the atom. So this separation is called the awkward electrons. So now we understand very clearly. So the electron interactions is based on materials metal insulated transitions. So these interactions we are going to be dealing with study in a study in a condensed matter physics. So this is one criteria. The another criteria, electron interaction means what will different type of reaction will occur, like a positive charge, or like a same series of energy, negative. But is a positive, the same group of atoms or same signs will be interactive, like a boy, like a girl will interact each other, which means the electron when interaction with the same potential or quantized energy means with different reaction may occurs. That different reactions may occur. That means it's four categories we are already discussed. One about the backscatter electrons, number two electron lasers, third number three secondary electrons, and finally awkward electrons. So keep in mind the electron interactions is nothing about in our mind. Quickly strike out the four gray areas. One backscattered electron, two electron lasers, third secondary electron, and finally awkward electron. In this case, Specifically, here we can see the various band gap, energy gap in the several semiconductors, several superconductors are given in the particular table. I don't want to go too deeply in the energy band gap of the supercapacitor at the transition temperature T is equal to 0. I don't want to go too deeply. This is very simple. But before that, here in the particular day, in the particular slide, it is very important to understand. I mean, what I try to say, first we want to be discussed here. In the discuss means what I'm saying here, what is mean by the first order transition and what is mean by the second order transition. So the first order transitions here I want to be say the first order transition means the first order phase transition means the energy band gap decreases. Keep in mind the energy band gap decreases continually to zero as a temperature is increased into the transition temperature as shown in the graph. So this graph means the energy band gap gradually the energy band gap gradually decreasing. For example, the energy band gap gradually decreasing until zero. But when the temperature is increasing, when the temperature is increasing. So this called first order phase transition. Keep in mind the energy band gap, keep on the energy band gap, keep on the energy band gap decreasing, vice versa the temperature as well increase, the temperature is increased into the critical temperature. So this is called the first order phase transition. It could be is called the latent heat. So in the first order transition we are going to be study about what is the latent heat. So that means in the graphically we are going to be see discontinuity in the energy gap, discontinuity in the energy gap. Alternatively, for our understanding now, here what does it mean the second order phase transition? In addition, second order phase transition we are going to be study about the no latent heat, the discontinuity in the heat capacity. So the first order transit, the second order phase transition means is a zero magnetic field. Transitions in the zero magnetic field from the superconducting state to the normal state is observed is called the second order phase transition. So just for the comparison, I hope you understand. Just I want to be comparison here, right? The comparison means is the first order phase transition means it are going to be talk about the latent heat. And by graphically we are going to see the discontinuity in the energy gap. The second order transition means we are going to be discuss about no latent heat because there is a discontinuity in the heat capacity. So keep in mind here is a heat capacity is a energy band gap. I hope you understand. Otherwise you can to revise and review the video again. Hope you understand. Otherwise if you have any doubt or clarification just to post your comments and discussion into the chat box. For instance, here I am not presenting of explanation the specific slides here, but rather what I am going to say here, I don't want to go too deeply here. Already we discussed in the graph. So in the particular route, just I want to like to address here about the about the nuclear con about the nuclear con about the nuclear con quadrupole sorry nuclear quadrupole contribution. So the nuclear control contribution is about the heat capacity of a gallium in the normal superconducting states. The normal state is restored over the 200 Gauss field as electron lattice. So see you can hear electron lattice at low temperature. You can see is a electron lattice at low temperature. During this is called the nuclear quadrupole contribution. So keep in mind here the graph it's growing like this. For example, here is the superconducting states, right? But here this one, see, here is the normal states. The normal states you are talking about the nuclear quadrupole contribution. I hope you clear. In addition, look at here in the graph already in the previous slides we discussed. So the energy band gap keep on decreasing until zero, and the heat temperature is increased until reach the transition temperature zero. So this one is called the what does it mean called the first order phase transition. So first order phase transition. So on this, so what I'm trying to reach you, Now on the previous slides we used the same graph, and there is a zoomed, and here is a zoomed graph that will help you understand the values and notations. So taking this into consideration, as a result of their remarkable heat capacity, superconductor are highly effective devices. It is my hope that you were able to gain a better understanding based on what is the electron lattice interaction, what is electron-electron interaction, and what does about first order phase transition, and what does it about the second order phase transition. First order phase transition is related to latent heat, and second order phase transition is related to the what does it mean? It's second order phase transition is related to the no latent heat. So that only I want to repeat again. I hope we are able to gain a better understanding of the energy gap by doing so. So you are most welcome to subscribe my channel and watch the video. I hope you like it, share it and subscribe it. Let me know what you think so that we can make our next video even better. So this video will continue our discussion further of microwave and infrared properties. I hope you see you again soon. Thank you for watching.